Hello everyone, this is lecture 8 of PEC. Let's talk about a new concept, the port. Here are two terminals. If they satisfy the condition that the current flows into a terminal is equal to the one flows out of another terminal, if the two terminals meet such a requirement, then they form a port. We call such a condition the port condition. Obviously, the resistors and the independent sources discussed before are both two terminal elements. So you can see the current flows in here is equal to the one flows out here. So you know the current flows in here is equal to the current flows out here. So you also know that the current flowed in this equal to the flowed out. So a two-terminal element must be a port. But if we consider it abstractly, for such a circuit, it has four terminals outside. Then the current flows in from this terminal and the one out from here are not necessarily equal. If they are equal, then we call this sub-circuit two-port. About this, we will discuss in detail at the subsequent lectures. In this lecture, we will only discuss the one-port network. The purpose of talking about the port is to help you understand the abstract concept. That is to say, in the network, it is not only a resistor, a voltage source, or a current source. It may be a very complex network composed of a number of voltage sources, current sources, and resistors. Generally, we only care about the relationship between the voltage and the current of their ports. Then let's discuss the relationship between the voltage and the current of one port for defining passive network and active network or passive and active port. Please see the network. It is a one-port network. You and I are variables. You make a judgment. For the one port, you and I are associated reference directions or not? Yes, it is associated. For the current flows in from the positive of the voltage, we now give the definition of the passive one port. We assume first that the current and the voltage are zero at the time of negative infinity. This means that the whole system has no energy in a very long time ago. This assumption conforms to the physical condition generally. For any time, if the integral of the instantaneous power absorbed by this port from minus infinity to this moment is no less than zero, then the port is called a passive one port. As long as there is any moment at which the integral is less than zero, we call the port active one port. This definition seems to be very boring and difficult to understand. We will discuss two examples. For a resistor, please note that we represent the resistor's voltage and current reference directions in the associated way. We calculate the formula. For resistor, if the voltage and the current are associated, as we know, you can use Ohm's law that U equals R times I. There are two I tau. It is equal to R times the square of I tau. In this lecture, the resistance is always greater than zero, and this port is always greater than zero. So it is greater than zero. So this means at any time the instantaneous power consumed in resistance by the internal from the minus infinity time to that moment is always greater than zero, so it's passive. So the resistor is a passive component. Similarly, let's discuss a voltage source. The reference directions of the voltage source are defined non-associated. The current flows in from the negative of voltage. So in this case, if we want to use this formula for calculation, we have to reverse the direction of the current or the voltage. We reverse the current here. Now this formula can be used. As for voltage source, we know that U is equal to Us. So now this integral is greater than 0 or not, depending on the numeric values of I tau. For general applications of the voltage source, if it's connected to a resistor externally, if the resistance value is R, you can know that I is equal to Us over R and it is greater than 0. So the minus Us over R is less than 0. So we can see that it is an active element. It confirms to everyone's common sense. A resistor is a passive component and a voltage source is an active component. Because of this discussion, we often called the associated reference directions of the voltage and the current the passive sign convention. The non-associated reference directions of the voltage and the current is also called the active sign convention. In the future lectures, we will make no distinction of the passive sign convention and the associated reference direction, also no distinction of non-associated reference direction and active sign convention. That's the end of this lecture.